Welcome to Lights Out. I'm John Weiss.
And I'm Andy Henderson.
And today we are going to talk about getting connected. We've spent a lot of time on the show speaking about the different stages of evolution of these types of projects in IoT and emerging technologies. And the first step is always getting connected. So that's what we're going to talk about.
We have Rich Nagle with us, who has a deep background in getting stuff connected. And you'll hear from all the way from telco to factories to healthcare devices, you name it, he's done it.
Thanks so much for joining us, Rich.
Nice to meet you guys.
Yeah, happy for you to be here. Hey, can you tell us a little bit about who you are and what makes you qualified to talk about what we're going to be talking about today?
Sure. Well, my name is Rich Nagle. I've got an engineering background, and for about 20 years or so, I've been involved with connecting devices or making the devices for connectivity in one way, shape, or form. So for about the first 6 years, I worked on chips for a telecom company. And then after that, I got involved with mobile application development back around late 90s or so. That went through a few different companies, which was a lot of fun to do different startups and create applications. And then I got involved in IoT. Back then it was called machine to machine in about 2010. So for the last 10 years or so, I've been involved with working with companies to connect devices to solve their business problems. I'm currently working as director with Software AG in their IoT and analytics group. So happy to be here and happy to talk more about connecting devices.
You and I have worked a lot in the past getting people connected in industrial settings and factories and outside of factories too, right? Supply chain, logistics, all this stuff. And we've spent a lot of time on this series, but also just in the real world, talking about the maturity and evolution of IoT and emerging technologies. And we always start talking about, okay, the first step is to get connected. Everybody's done that already. Let's focus on steps 2, 3, 4, and 5. But the reality is, as you painfully are aware, it's not so trivial to get connected, right? I would love to get your take on what are some of the challenges, pitfalls, things that people should be aware of just starting out when it comes to getting connected to a piece of machinery or an asset in the field.
Yeah, it's a good question and a broad topic. And, really when you start with or even considering, a device to connect and all that, I truly do think it's probably the most difficult area of IoT. Hate to say it that way, but the biggest bump to overcome, because there's just so many different choices of devices, different protocols to consider, different environments they need to go in, and different goals that they're supposed to accomplish. And so there's a lot that goes into choosing the right device for the task or retrofitting a device that's there. But really, you got to start with the goal, right? When you're connecting devices, what are you hoping to solve? What data do you need? And once you figure out what the data is, you got to figure out where it's at. And then hopefully you've got a choice of devices there that help enable you to get at that data. So, for example, there's all different types of, in fact, I got a bunch on my desk here I can pull up and show you. But different devices that have different peripherals. The first thing you need to consider is where that information's at. Maybe it's a sensor or a control, and that might hook up to a GPIO pin, a general purpose input output. And then that could be sent off to the cloud for an IoT solution. Or maybe it speaks an industrial protocol. We run into Modbus a lot in the field, which is a serial protocol that's been around since the 80s, and it's kind of the de facto standard for a lot of industrial products. And so for IoT solutions like remote compressors or generators or whatever there might be, a lot of times we'll hook up to that protocol, get the data out, and then send it off to the cloud. Medical devices, maybe they might require some kind of custom development on a Linux or Windows operating system to connect those devices. So you're really writing a custom agent to be able to connect that device. And so those are, just some examples of, getting connected. And it's just three examples there of the many different ones that happen or can happen. And so I guess that's part of the problem, is there's just so many different choices there for what you got and where to get the data that's available there.
In typical IoT flavor, there's not one size fits all approach to getting connected, I guess, huh?
No, not at all. Not at all. And a lot of choices out there about how to do it too, which makes it an interesting task to conquer. And so, yeah. So I guess basically just to frame it up for people that might be new to this or trying to understand, really it's those local area protocols or where that data is at to consider on the local side. And then on the wide area side, there's different ways to connect that data to the cloud. That might be through an intermediate gateway, and then it might go off to the cloud in one way, shape, or form. There's a number of different physical protocols to be able to send data up. Maybe it's narrowband IoT's new, or Wi-Fi, or wherever that interactivity exists. And then there's application level protocols, which, not to get too deep, but HTTP and MQTT are the ways that we can send information to the cloud and back down to the devices. And so we can dig deeper into those areas if we want to, but that's just really the main things that you have to consider when you're talking about the communication protocols for a device.
So in a lot of those brownfield examples, you are taking a look at your device and trying to figure out what it takes to, what might be available to me on that device already, or also what might I have to add in order to get at more data, more information from that device. On the greenfield side of things, it's probably you're doing more of that, but in the specing of the machine. What are some key considerations in, I think you've done a lot. The way what you've discussed already covers a lot of the brownfield side of it, but on the greenfield side of it, like what do you see as being common from equipment builders, for example, today, and are key considerations when maybe looking at buying new equipment, new things coming into a factory environment?
Yeah, for a factory environment, I think that the standard protocol there is typically OPC UA. This seems like the more modern protocol that would be there. It's easier to connect to that, and there's a lot of issues with the old OPC protocol that takes care of for security and other issues that were attached to the OPC old protocol. So, like in manufacturing, it does still vary quite a lot. There's never like a pure greenfield that I've come across, to be honest with you. So it's hard to say. And a lot of it is that, retrofitting the existing, older PLCs that might be there, the different various ones that might, support OPC or OPC UA or Ethernet over IP. Many times we'll use gateways. There's software that can connect to those, Kepler and others that are used to be able to get access to those devices. Sometimes we use gateway devices like this. This is an E1 Flexi that you see here. And this it connects up to a whole bunch of different types of PLCs. And so if you want to add some hardware there and then do a little custom Java development to be able to take that, address that data that's in those PLCs and then send it off to the cloud, that's what a device like this could do.
So help paint the picture a little bit, Rich. So you just, for folks who aren't watching, but they're listening, you just picked up a box. It looks kind of like a small, I don't know, a little small electronic box, like, I don't really know how to describe it, right? Like a tiny little cable box looking thing, maybe. It's got some inputs, some outputs. It's a plastic block. And so what does this actually look like? If I walk into a manufacturer, they say, hey, I've got this lathe over here, or I've got this milling machine, whatever it might be. Maybe it's a die stamp piece of equipment, right? It could be anything. I've got this piece of machinery here and I want to get some data off this thing, right? I've got a PLC, so it's somewhat intelligent, this piece of equipment. And you basically, if I'm understanding correctly, you would take this box, you would wire it into the PLC in I would imagine an uninvasive way, so you're not disrupting production, right? And this box now gives you the power to start to extract some data to do something with it. Is that a good way to summarize that?
Yeah, that's really it. At a high level, that's exactly what we're doing. There's various different, types of PLCs that are out there, but yeah, we're connecting to it typically through an Ethernet connection. And then speaking that language that those different PLCs might have. This is what this box does. It translates that, so it can talk to all of them. And you can address all the information that's out there, so you can read in their address mapping and then take that off to read the pressures, the temperatures, the humidity values, whatever those might be, and send those off to the cloud.
As somebody's thinking about the cost of connecting, like, I know from my own personal experience, the cost can have a huge range, but are we talking hundreds of dollars, thousands of dollars, tens of thousands of dollars on a per machine, per asset basis? Like what's your typical experience?
Yeah, what's nice about this, it's in the range, it all depends, right? But typically, I think something like this would be in the hundreds of dollars to be able to hook multiple PLCs on a local area network there, and then send it off to the cloud. Sometimes you'll have, a full edge hybrid solution that's put onto the factory floor just to do more heavy lifting, maybe analytics too. And you might have an industrial PC that might start to range into thousands of dollars there, with the high-end processors and lots of RAMs and in memory for storage to be able to do your machine learning type of applications and just ingest a lot of data and do kinds of different things there. So you might have a heavier edge component that's put on factory floors just to do more. If it's just pure connectivity, probably in the hundreds of dollars to be able to put some hardware down there, connect the stuff, and send that information off to the cloud.
I was going to ask, like, so like, what's best case scenario from a cost perspective, and worst case? And to elaborate just for a second on what I mean, like, I can imagine best case is there's a newer model machine that has a control on it that already speaks one of the protocols. It's easily consumable. There's an Ethernet port on it. You can just plug it directly into the network, and as long as you have a piece of software on a compute device somewhere talking to it, that's really what you need, right? And then it gets progressively more complicated and expensive from there. Is that a fair?
Yeah, that's right. It's getting cheaper. That's what's nice. It seems like there's a lot more devices out there that speak a lot of these protocols, and it's competitive, and so it's getting cheaper. But yeah, best case, maybe it's a device for a couple $100 that, obviously environment needs to be taken into consider. Sometimes you pay more for that, especially if it's any kind of just for whatever the environment might be, high temperatures around any kind of flammable materials or things like that all need to be considered when choosing a device. But if it's just an open factory floor where everything's safe, maybe it's a couple $100 that will speak that language and be able to send the information off.
Incredibly attainable compared to some of the prices that these things used to be. If you remember when some of these, quote unquote, smart PLCs were first coming out that finally exposed these proprietary protocols, these things were not cheap, right? I mean, you were in the thousands and thousands of dollars per machine or, per control. So it's interesting now to see best case scenario, Andy, to your question, right? I think best case scenario, you've just invested in a new PLC and boom, the thing is going to communicate over something like MQTT out of the box, right? Now you don't need to play with a new piece of hardware, and now you're almost you are in a greenfield type capacity, right? Because you don't have to come back in and retrofit something. It's going to communicate and connect out of the box. And what I have found in my experience retrofitting in brownfield is that the cost is really going to be dependent on the hardware that you pick. And I'm sure Rich would agree with this. In fact, Rich and I both have worked on projects where we've implemented very, very similar pieces of hardware to what he just showed, but at roughly 10x the cost, right? Just because it's a different vendor with a different price point, and it does some different things, but fundamentally, at the end of the day, all it's doing is getting your data out of your machine and into either an edge, compute loop or a cloud compute location, whether it's an IoT platform or whatever it might be. So I think your mileage may vary depending on what you select.
Yeah, for sure.
Certainly.
So if we boil this down just a little bit and help folks understand some of the things to keep in mind when you go into a facility, right? So a facility could be anything, right? An industrial area, anything. You have one of these boxes, you connect it to a PLC, you're pulling data out. If I'm a plant manager or a factory owner, whatever, what would I need to be aware of before I start this journey to go buy some of these boxes and try to connect my machines? Do I need to be cognizant of having good Wi-Fi? Do I have to have, a networking infrastructure in place so that I can run Ethernet cables to all my machines? Do I need to have any kind of special compute power to do something unique, right? Like what are some of the things that you've seen people would have to even start this journey?
Yeah, I think you hit some good points there for connectivity and security, right? You're going to be able to connect devices to the internet, right? So security is paramount. How are you going to do that? Are you going to have a dedicated Wi-Fi environment locally just to be able to access those specific devices, or an Ethernet LAN that's just dedicated to that? And how you button down security there is important. So that's probably the most and biggest concern that always comes up, and it probably should be addressed early on about how you take care of that. Other things there's always talk about getting on the customer's Wi-Fi, maybe you're a manufacturer of machines that go off to different plants, for example, or even your own manufacturing plant that can get congested depending on how much data you're sending, right? So you have to make sure the ample bandwidth's there to be able to handle all the data, to make sure you don't have, especially if it's a remote setting, that's why you would do IoT. You can't just walk down and fix it, even though that's convenient to store all that data for understanding manufacturing. But if it's remote, you're really killing your ROI if you have to go out and address those types of issues once it gets installed. So bandwidth is a big concern. Power is usually available everywhere, but power in the environment settings, where's that thing going to sit, and is it going to be, subjected to any kind of extreme temperatures or humidity or whatever that might be, is also something that needs to be considered in the source of hardware. So those are some of the things. Sometimes, cellular is, and more with 5G, the pitch there, I think we'll see how that all evolves, but it might make sense to have a 5G connection with very low latencies and very high speeds to be able to set up this secure environment inside of a factory. Then you have to consider things such as antennas and coverage and, for typical stuff that you would have to do for wireless protocols. So that's a consideration there too, as well as getting into another topic. These are just for specific endpoints, but there might be a gateway that collects all these things intermediately and then sends all information off to the cloud too. So you've got some options there where it might have a very cost-effective local area protocol, aggregate that stuff up, and then send it off to the wide area network or the cloud through a gateway as well too. So a lot of things to consider. That was a lot at once, but some of the things to keep in mind.
There's a factory I was working with, and we were trying to determine the solutions. We tested a few different things, and one of them was, the standard. I guess it was at the time it was probably still 2.4 gigahertz wireless. Yep. And so we had an access point. There were a few access points throughout the factory, and we ran a test on a few machines by connecting them to the Wi-Fi, and every once in a while the connection would drop. And what we found, there was a few factors, right? We went out on the floor with our I forget what the device is called, but basically it reads all the different wireless signals in the area. And so we found that there were some conflicting wireless signals from like a vendor of a piece of equipment that was using it. Had their own ad hoc network to transmit like consumable data out, right? So that was conflicting with our network. And then the other thing was the drop was related to when this massive crane passed by the area. So there was a disruption to the actual signal whenever this massive metal thing moved by. And so what we ended up doing was effectively saying everything has to be physically connected with wires in order to guarantee a reliable connection. And then that came with a whole bunch of other requirements. So everything inside of this facility had to be in rigid metal conduit, and what's common in a lot of the places that I've seen is you might have like a wire track, and you'll just drop wires from the wire track down to the point where they need to be. And that can work, but in this particular environment, we had to have rigid metal conduit on the wiring, and that added in some more costs. So and then we had to build out this backbone, if you will, of switches and things throughout the plant. And by the time it was all said and done, it was a few $1,000s, like maybe even on the order of tens of thousands of dollars per machine inside of this factory in order to have a reliable connection to those devices. And I feel like that's probably on a more extreme side of things. And the other thing that did is it took time to put all of that stuff in. So like where we were hoping we would be getting data and driving value in a few weeks, it ended up extending things out. And again, I think that's probably on the extreme side of things. I'm just wondering, you've done more of those than I have. Would you consider that to be extreme as well, or is that even typical?
No, I think a lot of people just naturally gravitate to wireless because it's there and it exists for, people to hook up their Wi-Fi and they get it, and you kind of take it for, for granted. But you're absolutely right. If there's mission critical stuff, wired is certainly, something that's used. And if there's, the cost can be contained and it works for the environment that things are being deployed in, then yeah, that's certainly a more reliable way of doing it. You brought it up. I mean, with wireless, there's a whole bunch of things that can affect the physical quality of that signal, right? So a crane or some kind of big piece of metal gets in between that wireless access point and where it's going to. Things can go south there and you don't get the data. And if it's mission critical, you need to get it. So it's a great scenario you brought up and something that should be considered as well.
I would say probably atypical having to have to have your wiring in a metal protection everywhere. I'm not so sure I've seen that everywhere at least everywhere I've been, especially if you think about starting a little bit smaller and like we've talked a lot about, Andy, getting a quick win. Typically people are not building out a critical infrastructure quite like what you described just to get started, right? That sounds like a very mature initiative where they're planning already for scale and production quality implementation, which I would say is a little bit atypical out of the gate. What I have found in my experience, most factories I go into, and I'll work with somebody in IT to basically give me a network drop, which will be, for anybody who doesn't know what a network drop is, it's basically an access point or an entryway into the network of the factory. And typically what people will do is they'll give you a little router, just like you'd find in your house, that lets you plug other devices into it to share the signal, right? They'll give you a router, but they'll kind of quarantine it off from the factory network. So it's an isolated little network box that gives you enough access so that you can get out to the internet if needed to pull some files down, something like that. But it will restrict the access in a way that you cannot communicate with any other pieces of equipment or computers or anything on the larger factory network. That seems to be a pretty typical approach, and definitely not wrapped in metal either. Usually this is something that's draped on the floor that OSHA would come in and have a field day about, but that's just the reality of how we get down and dirty sometimes, right?
Yeah, and you're exactly right on that. That wasn't the first iteration of this. The first iteration was running cables, much like you're saying, and zip tying it to other pieces of conduit that were available to run it, and using I think the first iteration actually did use a home router as the switch to connect it all to. Yeah. So you're exactly right. That was more of a once it is an established thing that you're going to do, project you're going to do, then
because you've decided, right? You've decided this is going to work for us. We're going to make an investment. Now we're going to lay down the critical infrastructure needed to actually bring this thing to production quality. Whereas a lot of projects, I think, in this space are still in the proving the value mode, especially if you're just talking about getting connected. You've got a long journey ahead of you, as we've talked about, right? So I think as the bare minimum or entry into this, not being limited by some of those constraints can be very helpful. If you're in an environment that it's safe to do so, to enable you to quickly plug in and get this infrastructure that we've talked about, up and running, I think that's pretty. Um, I think it's pretty advantageous for you to be able to be successful, also because it lowers some of the barriers that you would have to face otherwise.
Mhm.
Yeah. One thing that we've talked a good bit about today, Rich, is protocols. I've heard the word protocol a few times, and I wonder how familiar everybody listening and watching is with truly what a protocol is. Um, my understanding, and I'd love to get your take on it, but I'm a pretty simple guy. My understanding is really a protocol is just another way for saying a language that something speaks, right? If I've got a machine that uses OPC-UA as a protocol, or I have a machine that uses MQTT as a protocol, or whatever it may be. These are just different. These are just different languages. It's kind of like saying, English and Spanish, right? Both are communication mechanisms or types, but they sound a little different, right? Is that a fair way to really simplify it?
Yeah, I think that's right. It's a protocol, just a way of doing things, right? It doesn't apply always to just how machines talk, but just protocols on how things get done. And so it's an established standard in most cases or not necessarily a standard, but something that's known where, in electronic speak, maybe some ones and zeros are going to get set from one place to another. And those are put in certain packets in a certain way that's organized. And so when it gets to wherever it needs to go, that can just make sense of those ones and zeros. So you think of the post office and a mail. Well, it might be a protocol for me to mail you a letter, even though that's dated. I would put an address on it, and then the mailman would know where to route that through to the other mailman, and it get delivered to you, and then you read the information inside. So it's similar to that in many ways, just a process of sending data back and forth.
And also important to note, of course, in many factories, be it greenfield or brownfield, there's a great chance you have a wide variety of equipment, right? And all these things are speaking different languages, right? So that's one thing that is really important to remember, even just getting started. It's really important to keep in mind connecting one machine. You may have to do some things a little bit differently when you connect the next machine, because it might not be the same PLC manufacturer. It might not be the same type of protocol that it's speaking, right? You might have to massage the data and make it look a little bit differently before you can use it the same way you did it the first time. Just some food for thought.
Yeah, no, good point. Very good point, because it does vary quite a bit.
And it's one of the things that we found is also a good idea to, put some forethought, some thought ahead of time in terms of like naming conventions, for example, of signals, right? Instead of, because what'll drive people analyzing the data crazy is if you have machine underscore temp over here and it's all lowercase, and then over here you have machine 12596 with dash capital T temp, and they're the same pieces of data, but they're just labeled differently. So having some amount of rigor, right? Again, you don't want to, that rigor can probably turn into a multi-month exercise where everybody has an opinion and you never really get things done, but some amount of rigor around how you're going to name things so that you don't drive people crazy at the end.
Years ago in the big wave of big data, Andy, I think we called that a data dictionary, right? You got to have that data dictionary.
Yeah, for sure.
I don't know if that's cool anymore. Maybe I shouldn't date myself like that, but there was a time, folks, when that was cool to have a data dictionary.
Well, I think it's still cool, but the one of the things that I've seen a lot is that there are, we call them protocols, or I'm using the word protocol again, but it's more of it's a data standard that
naming convention
that tries to dictate that, and trying to get industry consortia around it for everybody to use that to use that standard, as opposed to like because Rich, you can correct me if I'm wrong, but the protocol, right? It doesn't really dictate that thing. It really dictates what you were talking about a moment ago, how the data is addressed and transported. But like when it comes to the specifics of maybe the name or the units being used for the data item, none of that stuff is dictated by the protocol. It's still left up to the to the implementation. Is that a true statement?
Yeah, that's right. That's right. You know, and in your absolutely, it's a great point about your naming conventions and schemes, because if you don't take care of that sooner, when it's easy to do or easier to do, it's going to become a mess later. And we've seen that just integrating different systems and trying to normalize one temperature from another across the same machines is an effort that's just problematic outside of the protocol, but something that needs to be considered when you're connecting devices and what you're going to do with that data to make it easy for you to understand it.
It reminds me of all the emails I've received in my inbox that have documents with underscore final V2 final. And you, look, is this the last one or not, guys?
We digress, but timestamps drive me crazy. Timestamps, you think it'd be so simple, but just the order of where things go in a timestamp, and is this UTC or is it
epoch? I mean, there's all these different, yes, I'm with you on that one. I'm very, and I can't tell you actually how many projects I've worked on in factories where timestamps were the cause of many restless nights on site trying to build dashboards for people, and you can't figure out why on earth does this Pareto chart not match, you know, when the event actually happened. And oh my gosh, because you've got 5 machines speaking 6 different formats of a timestamp. It's incredible. Yeah. I feel your pain on that one.
The other thing, Rich, that you mentioned a few times was the environment. And, you know, this is probably old hat to a lot of people, but I know my first time through, it was something new to me that there's a rating system for determining like dust and water intrusion, right? I think it's a military standard that dictates that. But then you also mentioned other hazardous conditions, fire and things of that sort. Like, it might be worth just really quickly explaining what, say, IP67 means and what some of the other standards might be, just for people to have a bit of extra context if you're thinking about going down this path.
Yeah, so the IP system that goes from a scale of 1 to 8, you're right, it's for water and dust resistance. And typically 6-7 is often used. I forget which one's first, water or dust, to be honest. I'd have to Wikipedia and look it up. But, you know, that's the standard for outdoor type of protection, where it's water resistant. I think it might be able to be submerged up to a meter or something like that. Don't quote me on that, but it's in that standard there. And the dust resistant, it would just protect the electronics there from, you know, affecting the circuit layout and preventing malfunctions from happening, right? So those are important to consider in those environments, and like brought up IP67 something on for that. Others like NEMA 4 enclosures are typically used in outdoor environments for the same reason, just to be able to add that protection. You'll also come across maybe Class 1 Div 2 or Class 1 Div 1 devices for oil and gas to make sure they're intrinsically safe, so there's no exposure to the electronics that could ignite any of the gas that's in that environment for safety reasons, obviously. So some of the ones that you come across as well.
Yeah, cool. Thanks for that.
Yep. Yeah.
I think we're quickly approaching our time, Mr. Nagle. So I would like to maybe wrap today. If you could share some final thoughts, last minute piece of advice, guidance for folks that are brave enough to start this journey with us and start connecting some machines. Any last final thoughts?
Sure. You know, it's something that we've done enough of. It can always be done, right? I think with some smarts going into it about what you're hoping to accomplish, and keeping things simple to do a proof of concept to make sure it works, and then expanding that out to be more robust is a good way to approach that. And the other thing is you know, there's just always newer technologies that should be considered. So things are getting easier. You know, with a lot of different things. We've got a demo at MXD in Chicago. There's some really cool technologies that are being applied for connecting things. One is an analog gauge, which, you know, it might take a lot of effort to actually, you know, connect to that thing. But what they've done is they put a simple $120 webcam in front of it. And it's using computer vision techniques to read that gauge, that dial, and giving the information out of that. So it's a great way to connect some brownfield stuff, or just apply connectivity to devices in a different way that you wouldn't have thought of. And so there's always those types of things that are out there that should be considered in what we do every day, and hopefully we can help you with those choices.
Awesome. Thanks so much, Rich. And as always, thanks to our viewers, our listeners. We would encourage you to like and subscribe. Leave us a comment. What's working for you? What have you connected? Did you have problems? Was it easy? We'd love to hear from you. Until next time, we'll see you. Thanks so much.